Hello, good morning, and welcome to today's class. Today's class is a continuation of our previous class, which we introduced simple equations. And in our previous class, we looked at the change of subjects of formulae. And in today's class, we'll be looking at variation. And variation is a relationship between two or more quantities, whereby a change in one quantity leads to a corresponding change in the other quantity or quantities, as the case may be. And variation can be classified as either direct variation, inverse variation, joint variation, or partial variations. And this relationship can be represented as on the board, which we have A is directly proportional to B, where the symbol means varies directly with or is proportional to. At the end of this topic, students should be able to solve problems involving direct, inverse, joint, and partial variations as one of the objectives of today's class. And also, you should be able to apply variation to physical laws and real-life situations. Okay, let's look at direct variation, which is one of the classification of variation. Now, a direct variation is a relationship between two or more quantities, whereby an increase in one quantity leads to a corresponding increase in the other quantity, or a decrease in one quantity leads to also a decrease in another quantity. And I'm going to give you some examples, or some real-life examples, and show you how you can calculate that. Now let's look at what we have on the board. Let's look at direct variations. We said y varies directly as x is also written as y varies as x, where the variation sign also means is directly proportional to x. Now in calculation, y varies directly as x can be written in an equation form as y is equal to kx, where k is a constant of proportionality, or simply a constant. And that means if x is doubled, then y is also doubled, and if x is halved, then y is also halved. We have example 1 on the board, that if p varies directly as r and r is equal to 12 when p is 10, that we should find a, the relationship between p and r, and b, which we should find r when p is equal to 6. What we are expected to do in this case is, we should first of all, when you have a problem on direct variation, the first thing you should do is to first of all try and express it in variation form, after which you convert it to an equation, and that will give you the relationship between the two variables. You also get to look for the constant and resubstitute it back into that equation, and that gives you the relationship. So I'm going to use this example to explain further what I have said. Now, that if p varies directly as r, how do we write that in variation? We said p is directly proportional to r, and converting this to an equation, we said p is equal to kr, where k is a constant. We are going to make k the subject of the formula. With our knowledge of change of subject of the formula in the previous class, we will make k the subject of the formula by dividing both sides by r, and that will give us our k as the subject of the formula, where k is equal to p over r. So this is the value of k, but we are asked to find the relationship given that when r is 12, p is equal to 10. So therefore we said, let's get the value of k when r is equal to 12 and p is equal to 12. That means we are going to substitute r for 12 and p for k in this equation. So that becomes, we said, when p is equal to 10 and r is equal to 12, what is our value of k? We have it that k is equal to p over r, where p is 10 divided by 12. And if you reduce this to its lowest form, you discover that 2 can go into 10 and 12. 2 into 10 will give you 5, and 2 into 12 will be equal to 6. So therefore our value of k now becomes what? 5 over 6. We have gotten our value of k as 5 over 6. What we'll do next is to resubstitute k for 5 over 6 into that equation to get our relationship. So we have it that p is equal to kr, but we have gotten our value of k to be 5 over 6. Therefore p is equal to 5 over 6 times r, which is equal to 5r over 6, such that p is equal to 5r over 6 as the relationship. This is the relationship between p and r. And if you go up further, you discover that the question says we should find the relationship between p and r, which we have gotten, and b says find r when p is equal to 6. That we should find r when p is equal to 6. So b says we should find r when p is equal to 6. But we know that the relationship between p and r is given as p is equal to 5r over 6. So when p is equal to 6, what is r? We are going to first of all make r the subject of the formula, and thereafter we substitute p for 6. So I'm going to multiply both sides by 6, and that will be p times 6 will be equal to 5r over 6 times 6 over 1. 6 will cancel 6, and this will give us 6p is equal to 5r. Next is to divide both sides by 5. So I'll divide here by 5, divide here by 5, and this will cancel this, so that r becomes 6p over 5. But we are told that p is equal to 6, by given that p is equal to 6, and our r will be equal to 6 times 6 over 5, which is equals to 36 over 5, or 36 divided by 5 is said to be 7 whole number 1 over 5, or in decimal fraction we say this is equals to 7.2 as your answer. Let's take another example, and in this example 2, the question says the value of a varies directly as the square of b. How do we write that in simple variation form? That the value of a varies directly as the square of b, and we said in order to write that, you say the value of a varies directly as b squared. So this is what you will get, and writing that as an equation, you have it to be a is equal to kb squared. In the introductory part of the class, I told you that when you are converting from a variation expression to an equation, when you are to substitute, you have to replace the variation sign with an equality sign, and thereafter introduce a constant at the right hand side of the equation. Your constant may be k or any alphabet as you choose to. But note that most of the values of k, most of the values of constant, most of the symbols we use as constant is mostly k, a, b, or c. And for your variables, you may likely choose x, y, p, q as may be used, but that of x and y is mostly used as variables, and k is mostly used as constant. But you are at liberty to choose whichever alphabet you want to use as constant and as variables, so long as it doesn't confuse your listeners or your students. So we have expressed such a relationship as an equation. We are asked to find the relationship between a and k. We have it here, but we can't leave k, which is a constant, to be k. We have to find the numeric value of k. So I'm going to make k the subject of the formula, and thereafter subsequently resubstitute it back into this equation. Now, making k the subject of the formula, I'm going to divide both sides of the equation by the unwanted variable, which is b squared. So I will divide both sides by b squared. That will be a over b squared is equal to k b squared over b squared, and b squared will cancel b squared, where our k now is given as a over b squared. But note, we are given that a is equal to 3 when b is equal to 2. I will therefore resubstitute a and b for 3 and 2 in the expression for k to get the numeric value of k, which I will therefore resubstitute into equation 1, so that k now becomes 3 over 2 as the value of k. So if this is the value of k, I will therefore resubstitute it into this equation to get my relationship between a and b, of which the relationship is a is equal to k. Instead of writing k, I'll then write 3 over 2b squared, which is equal to 3b squared over 2. So my relationship now is a is equal to 3b squared over 2. So this is the relationship between a and b. In this next example, is still under direct variation, and we are told that if c varies directly as d and c is equal to 14 when d is equal to 2, that we should find the formula connecting c and d. So we go. If c varies as d and c is equal to 14, how do we write that? We say c varies as d. Writing this as an equation, we'll have it that c is equal to kd, and this is, let me call this equation 1. Let's get the value of k by making k the subject of the formula. So I'm going to divide both sides by d. This is equal to kd over d, of which d will cancel d, and my k is equals to c over d. Given that d is equal to 2 when c is equal to 14, I'll therefore substitute c and d for 14 and 2, so that I'll have k to be equal to 14 over 2, and 14 divided by 2 will give us 7. So having gotten my value of k as 7, I'm going to resubstitute it back into equation 1 to get the relationship, so that I'll have c is equal to 7d. as the relationship between C and D. Next equation says if D varies directly as T and D is equal to 24 when T is equal to 3, we should find the formula connecting D and T. By asking us to find the formula connecting D and T is still equal to saying find the relationship between D and T, of which we have been solving in our previous examples. So I'm going to write this in equation form, which is equal to D is equal to KT, and I'm going to make K the subject of the formula given D and T. I'll divide both sides by T, and T will cancel T, so that my K is equal to D over T, given that D is equal to 24 and T is equal to 3. So that will be 24 divided by 3, and 24 divided by 3 is 8. I will therefore resubstitute the value of K into that equation, and that becomes D is equal to, K has been gotten to be 8, so we'll have it to be equal to 8 what? 8T as the formula connecting D and T. Next is if X varies directly as Y, and when X is equal to 5, Y is equal to 20, that we should find the relationship between X and Y. So we have it that X varies directly as Y, which we write as X varies directly as Y, and as an equation we have it to be X is equal to KY. Now we'll make K the subject of the formula from equation 1 by dividing both sides by X. So we'll have it to be X over, dividing both sides by Y, we'll have it to be X over Y is equal to KY over Y, where Y will cancel Y, and we'll have our value of K to be equal to X over Y. Having done that, we will therefore resubstitute the value of K and substitute the value of X and Y into the expression with K to get the value of K, so that K is equal to, we are told that X is equal to 5 and Y is equal to 20, so you have to simplify it further. 5 can divide, is a factor that can divide 5 and 20, so 5 into 5 is 1 and 5 into 20 is 4, so that our value of K becomes what? 1 over 4, which will then resubstitute into equation Y, giving us the expression X is equals to 1 over 4 times Y over 1, where when you simplify you have X is equal to Y over 4 as your relationship between X and Y. The next question says if Y varies directly as the square of X and Y is equals to 98 when X is equals to 5, we should calculate Y when X is equal to 5. So what you do is to first of all get the relationship between X and Y, and thereafter you now find the value of Y when X is equals to 5. So let's go. We have Y varies directly as the square of X, so we have it as varies directly as the square of X. Writing it as an equation, we have Y is equal to KX squared. Okay, this is the relationship between Y and X, but we cannot leave K as a letter. We have to get the value of K given X and Y. So making K the subject of the formula, I'm going to divide both sides of the equation by X squared, leaving us with Y over x squared is equal to kx squared over x squared. X squared will divide x squared, leaving us with k is equal to y over x squared. Given that y is equal to 98 when x is equal to 7, so we are going to substitute 98 and 7 for y and x. So we'll have k is equal to 98 divided by 7 squared. And when you divide that, you are going to have k is equal to, let's simplify further, 98 divided by 7 squared is 49. And if you look at it, you discover that 49 is half of 98, meaning 49 can go into 49 and 98. 49 into 98 is 2, and 49 into 49 is 1, so that our value of k becomes 2. I will therefore resubstitute the value of k into equation 1 to get the relationship between y and x, and that becomes y is equal to 2x squared as the relationship between x and y. But the question says we should calculate y when x is equal to 5. So I'm going to use this equation 2 to substitute and get my value of y, because I have already gotten the relationship between x and y. So we have it that y is equal to 2x squared. So given that x is equal to 5, then y will be equal to 2 times 5 squared, of which when you simplify, you have 2 multiplying 5 squared, which is 25. And y therefore becomes 2 times 25, which is 50. So y is equal to 50 when x is equal to 5. This next example says x varies directly as t, and when x is equal to 64, when t is 4, we should find the relationship between x and t. We go straight ahead, that x is equal to kt, make k the subject of the formula by dividing both sides by t. You have it that x over t is equal to kt over t, and t will cancel t, giving you k to be equal to s over t. But we are told that x is equal to 64 when t is 4. So we are going to substitute the values of 64 and 4 for s and t in this relationship. So this is going to be x is 64 divided by t, which is 4. And when you simplify this, you discover that 4 can go. 4 into itself is 1. 4 into 6 is 1 remainder 2. This becomes 24. 4 into 24 is 6. So that 4 into 64 will give us 16. Being that our value for k is 16, we can therefore resubstitute k into equation 1 to get the relationship, and that will be equal to x is equals to 16t as the relationship between x and t. In the next equation, we are told that if a varies directly as b and a is equal to 3.6 when b is equal to 2, we should find the relationship. Now, expressing this, we have it that a is equal to kb and we are told that given that a is equal to 3.6, b is equal to 2, we should find the relationship. So I'm going to call this equation 1, make k my subject of the formula by dividing both sides by b. So we'll have it that a over b is equal to kb over b. B will cancel b, leaving us with k is equals to a divide b. And substituting values of a and b for this relationship, you have it at 3.6 divided by 2. 2 into itself is 1. 2 into 3 is 1, remainder 1. Bringing it here becomes 0.16, and dividing 16 by 2 will have it to be 8, so that our value of k gives us 1.8. Then you now substitute 1.8 for k into equation 1, and you have your relationship to be a is equal to 1.8b as your equation 2. So this is the relationship between a and b, that for you to get your value of a given b, you have to multiply the value of b by 1.8 to give you the value of a. Next is, if d varies as e and d is equal to 140 when e is equal to 38, we should find the relationship between d and e. B, I should find the value of e when d is equal to 176. So how do we do that? We first of all express this as an equation, which I'll say d is equal to ke. Okay, we'll make k the subject of the formula by dividing both sides by e, and this is equal to ke divided by e. E will cancel e, leaving us with k is equal to d over e. But we are given the values of d and e to be, when you substitute the values of d and e, that d is equal to 140 when e is equal to 35. So we are going to substitute it. This is 140 over divided by 35. And what can go between 140 and 35? You discover that 5 can go. 5 is the smallest that can go. So 5 into 35 is 7. 5 into 14 is 2 times the remainder 4. Add 0 to it, it becomes 40. 5 into 40 is 8. So you discover that we have 28 over 7, of which 7 can still divide, because 7 is a factor of 7 and 28. So 7 divided by 7 is 1, and 28 divided by 7 is 4. So that your value of k is equal to 4 over 1, and 4 over 1 is simply what? 4. Next, what we'll do is, we have gotten the value of k to be 4. We'll therefore resubstitute it back into equation 1, and we'll have the relationship as d is equal to 4e as the relationship between d and e. But we are also told that we should find the value of e when d is equal to 174. Okay, question B says we should find the value of e when d is equal to 176. So we are going to say find e when d is equal to 176. We've already gotten the relationship between d and e, and we are going to state it. That is what we'll use in solving for d. For e, we have it that d is equal to 4e. We can either use a direct substitution and simplify, or we'll simplify before we substitute. So we are going to simplify. We are going to simplify and make E the subject of the formula before we'll substitute the value of D. So in making E the subject of the formula, we are going to divide both sides by 4. So we have it that D divided by 4 is equal to 4E divided by 4, and 4 will cancel 4, leaving us with the equation E is equal to D over 4. But we have been given the value of D to be 176. So we are going to substitute D for 176, which is equal to E is equal to 176 divided by 4. And the highest factor that can divide 4 and 176 is 4 itself. So 4 into 4 is 1. 4 into 17 will go 4 times remainder 1. This gives us 16. 4 into 16 is 4. So that our value of E is equal to 44. That means when D is equal to 176, E is equal to 44. Now if you look at it, you actually see that they are directly they vary directly, because as D increases, E also increases. D was 140 when E was 35, and when D increases to 176, E also increases to what? 44. So this is what we mean by direct variation. Next, we are asked to find the value of P when Q is equal to 5. That given that P varies directly as the square of Q. So how do we write that in direct variation? We say P varies directly as the square of Q. Expressing this as an equation, you have it to be P is equal to KQ squared. And making K the subject of the formula, you divide both sides by Q squared. So we have P over Q squared is equal to KQ squared divided by Q squared. Q squared will cancel Q squared, leaving us with the equation K is equal to P divided by Q squared. So what we are going to do is to get the value of K and resubstitute it back into our equation 1. And we are told that when P is 12, Q is 3. So we'll have our value of K to be given as P is 12, that will be 12 divided by Q, which is 3 squared, and when you simplify this, is going to be 12 divided by 3 squared means 3 times 3, and 3 times 3 is 9. Now you simplify further, what can divide? You discover that 3 is the common factor that can divide 12 and 9. 3 into 9 is 3, and 3 into 12 is 4, leaving us with K is equal to 4 over 3. So our constant is 4 over 3. Resubstituting it back into equation 1, you have the relationship to be P is equal to 4 over 3 Q squared. We have gotten the relationship between P and Q, and we are asked to find the value of P when Q is equal to 5. So we said B when Q is equal to 5. Let me see. Is that what we have to find? Yes. When Q is equal to 5, we'll just use a direct substitution to get our value of P. So we have it that when Q is equal to 5, P, which is given as 4 over 3 Q squared, will be equal to 4 over 3 times q squared, that will be 5 times 5 over 1, and this will be equal to 4 times 25 over 3, and 4 times 25 is 100. 100 divided by 3 will give us 100 divided by 3. We said 3 here, 3 into itself is 1, 3 into 10 is 3 times remainder 1. Adding this 0 to it, it becomes 10. 3 into 10 again is 3, remainder what? 1 over 3. So this is equal to 33 whole number 1 over 3. But if you want to express it as a decimal, that will be 33.333, and it keeps 3 keeps reoccurring, and which we refer to as a reoccurring decimal. So you can just simplify it to be 33.3333 to 4 decimal places. Next says, if x varies directly as y and x is equal to 20 when y is equal to 8, that we should find the formula connecting x and y. So as usual, we say x is directly proportional to y. Writing this as an equation, we have it that x is equal to ky as the relationship. So let's get the value of k and substitute back into equation 1. We will divide both sides by y, making k the subject of the formula. This is equal to k. So if k is equal to x over y, what will be k when x is given as 20 and y is given as 8? So we will substitute that, and we'll have it to be 20 over 8, and 20 divided by 8 we said is equal to, when you reduce it to its lowest term, the highest factor that can divide 8 and 20 is 4. 4 into 8 is 2, 4 into 20 is 5, leaving us with 5 over 2 as our value of k. Substituting k for 5 over 2 into equation 1, you have x to be equal to 5 over 2 times y, which is equal to 5y over 2. That means that your value of x will be equal to 5 times your value of y divided by 2. So this is the relationship connecting x and y. B says we should find x when y is 7. So using the relationship, we are going to substitute y for 7 and get our value of x. So we say x when y is equal to 7, we say is equal to x is equal to 5 times 7 divided by 2, and this will be equal to 5 times 7 is 35 divided by 2, and 35 divided by 2, we say 2 into itself is 1, 2 into 3 is 1, remainder 1, making it 15. 2 into 15 is 7 times remainder 1 over 2, so that our x is equal to 17 whole number 1 over 2, or in decimal we say is 17.5 as your answer. So we have it that when y is equal to 7, x is equal to 17.2. And C says we should find y when x is equal to 10. So we have it that y when x is equal to 10. So we'll also use the relationship between x and y, which we got in our equation 2, to be x is equals to 5y over 2. What we can do is we can substitute and simplify. So I'm going to substitute 10 for x into this equation and then simplify. Whichever suits you, you can solve. Is either you simplify before you substitute or you substitute before you simplify. Both are still the same thing. So this is going to be 10 is equal to 5y over 2. We'll now make 5y the subject of the formula by first of all multiplying both sides by 2 to get rid of the fraction, and this becomes 10 times 2 is equals to 5y divided by 2 times 2 over 1. 2 will cancel out and we'll have 5y to be equal to 20. So in order for us to make y the subject of the formula, we'll have to divide both sides by 5. So when I divide here by 5, divide here by 5, I will get my value of y. So that y is equal to 20 divided by 5, and 20 divided by 5 is 4. So therefore y is equal to 4. So y is equal to 4 when x is equal to 2. So that is when x is equal to 10. So that's our solution. The next question says, if x minus 3 is directly proportional to the square of y and x is equal to 5 when y is equal to 2, we should find x when y is equal to 6. So I'm going to express this that given that x minus 3 is directly proportional to the square of y. So this is how you express it in direct proportion. You treat x minus 3 as one quantity, maybe as p or q that we have been using before. So we're therefore going to write this in equation form, that x minus 3 is equal to ky squared. Okay, and this is the relationship. So we are going to make k the subject of the formula by dividing both sides by y squared, and this will be x minus 3 divided by y squared is equal to k. Thereafter, we are told that when x is equal to 5, y is equal to 2. So we are going to use that information to get our value of k, that when x is equal to 5, that becomes 5 minus 3 divided by y squared, that is 2 squared. This is equal to 5 minus 3 is 2 divided by 2 squared is 4, and when you simplify this, it's going to give you 1 over 2, because 2 is a factor of 2 and 4. So when you divide both numerator and denominator by 2, we are going to have 1 over 4. Now we have gotten our value of k as half. We are going to resubstitute it back into equation 1. Now when k is equal to half, what is the relationship? We have it that x minus 3 is equal to 1 over 2y squared. So I'm going to simplify this further by moving every other constant to the other side. I'm going to move minus 3 to the other side. And how do I do that? By adding 3 to both sides, and that will give me x minus 3 plus 3 is equal to 1 over 2 y squared plus 3. So this becomes x is equal to, because minus 3 plus 3 is 0, is equal to half y squared plus 3. But I want to also get rid of this fraction, so I'm going to multiply every 10 by 2. So this becomes 2x is equal to y squared plus 6, because 2 times x is 2x. Half y squared times 2 is y squared, and 3 times 2 is 6. So this is the relationship between x and y, but you can either leave it this way, or you can say that x is equal to bracket y squared plus 6 all divided by 2. So to find x when y is equal to 6, so we have gotten the relationship between x and y. So B says we should find x when y is given as 6. So when y is equal to 6, what will be x? But we already know the relationship between x and y to be x is equal to y squared plus 6 divided by 2, which is equal to y is 6, so have it as 6 squared plus 6 divided by 2, which is equal to 6 squared is 36 plus 6 over 2, which will give us 36 plus 6 is 42. So 42 divided by 2, this will be equal to 2 into, since 2 is a factor that can divide 2 and 42, we'll use it. 2 into 2 is 1, 2 into 4 is 2, and 2 into 2 is 1, so that our answer is equals to 21. So when y is equal to 6, our x is equal to 21. And that brings us to the end of this class. In this class, we have been able to pick one of the objectives, which is on direct variation. In our next class, we are going to be looking at inverse variation and solve problems on inverse variation. In order for you not to miss this class, we kindly appeal that you subscribe to this channel so as to be notified when the next video is ready. Thank you and God bless you.